All right, good afternoon. My name is Vaibhav Gadkade. I'm a senior product manager in the Amazon AWS VPC team. And today I'm going to be joined by one of my colleagues, Mike Virgilia, who's a senior solutions architect at AWS, and also Josh Tate, who's the manager of one of our customers from Shure, is manager of network and security. And today we're going to talk about validating effective network access on AWS. So proverbially, as the saying goes, the network is the first line of defense between an adversary and whatever is your critical workloads. And it's nothing different on AWS as well, right? And so it's not only important as you think about how do you put in the right security controls in your AWS architecture, but perhaps just as importantly, how do you validate that what you have architected and designed for effectively meets your network security intents and your objectives? And how do you do it in an operationally efficient manner? And that's what we're here to talk about today. So the agenda here, we'll just quickly kick off things by talking about what are some of the commonly seen AWS network security patterns. And then we're going to be introducing a new feature that we launched last year called Network Access Analyzer, and talk a little bit more in depth about how this feature can help you validate your network security architecture in different use cases. And then finally, Mike and Josh are going to come on stage and talk about their experience in using this feature for their use cases. All right, so let's jump into it. So talking about various network security use cases, let's start off from the right-hand side, and I'm just going to enumerate and run over these one by one. So the most common one that you probably might have been dealing with is blocking access to non-essential ports and services, and making sure you're allowing traffic only from trusted or essential IP address ranges, right? Common examples you'll see in all of your security frameworks, don't allow SSH access, block SSH ports where unessential, block RDP access, make sure you don't have CIDR ranges too wide open, things like 0/0s. These are some common scenarios, and then you've got features like network firewall, network hackles, and security groups to help achieve some of this. Network segmentation, we come across this also quite a bit, right? Some of the most common examples is how do you isolate your production environment from your development workloads, or for example, you've got certain like PCI compliant applications that need their own separate virtual network. And customers use features like route tables and transit gateways to achieve this sort of virtual network segmentation. Then you have use cases like, you got EC2 instances connecting to S3, or for example, let's say you've got Active Directory running on AWS. How do you ensure that your workloads talk to those sort of resources and services, not over public internet, but over the private AWS network? And so for those sort of situations, you've got services like Private Link also that customers use. Next, customers often want to control access to how instances can communicate to the internet, and also how do they prevent those instances being directly accessible from the public internet. And that's, again, where you've got features like NAT gateways, as well as the recently launched network firewall that can help with that. And then finally, you've got things like inline security inspection. So if you're like a low secure, sometimes customers organize their network in terms of these security zones and require like anything going from low security to a high security zone to go through an inspection, firewall inspection. And that's, again, a combination of using route tables and features like the AWS Network Firewall. So you can use all these features in a combination and design and architect them in your environment. But as your network grows, as you onboard more workloads, onboard new business units and business lines, you'll have more accounts, more route tables, more VPCs, often like hundreds or even thousands of them. And most importantly, as your development teams start to operate infrastructure on AWS more autonomously, how do you validate that the security objectives that you had in place are still effective, and what you had architected for effectively meets your security objectives from a network perspective? And that's where we've got a new feature called Network Access Analyzer. We just launched it at re:Invent last year that can help you with this. It can help you identify paths to your resources running on AWS in a flexible manner based off an analysis pattern that you can specify. And it can also help you validate that you've got the right kind of security controls for the right kind of, and that your network security controls allow only the right kind of traffic to your workloads on AWS. And you can use some of these to also demonstrate that you are compliant with some of the mandates that you might be subject to. This is a feature that works purely based off configuration analysis. Just based off a static configuration analysis of your entire environment, you can do a whole bunch of analysis and find out even potential network paths that might not have traffic flowing through it, but still might be open, and that is something that this feature allows you to proactively go ahead and remediate. And because it is purely based off a configuration analysis, it's a fairly lightweight analysis without having to inspect or do a complete analysis of all things like traffic logs. To get started with using Network Access Analyzer, you can start using the feature in an exploratory manner. As part of this feature, as we'll see later on, we have a very flexible and very simple high-level declarative specification that you can express how do you want to evaluate network connectivity in your environment for. And you can start by doing an exploratory analysis of, let's say, which of my instances are, let's say, publicly accessible from internet gateways, as an example. Once you have identified what those potential paths and entry points are, you can also define, also using the specification language, which of those paths perhaps are compliant with your expectations that you don't want to get alerted for, versus which of them are things that you don't want to have happen in your environment. And then once you run the analysis, this tool can help you figure out and identify what those are potential network paths that are against your network security expectations. All right. So to create those sort of, I refer to these high-level declarative specification. In this feature, we have this construct called as a network access scope. It is something that you can create either using the VPC console or through a simple JSON document. And I'll demo those to you shortly. But essentially, this is the structure of it. It is essentially nothing but a pair of source and destination resources or resource sets associated along with an optional traffic type that you can specify. And when you specify this sort of a match condition, the feature essentially runs an analysis and finds out all possible network paths between your specified source and your specified destination for your specified traffic type. So let's say I had, what does this look like in the console? As the source, I have, you can do it based off resource types or resource IDs, but let's say I do it based off resource type. I select that my source is all possible internet gateways in my account, and my destination is all possible network interfaces in my account. So this is not just EC2 instances, but anything basically in your account that produces a network interface. So this could be, let's say, an RDS instance that has a network interface, or an EMR, or an OpenSearch cluster that is a network interface in your VPC. You would get findings or network paths of all of those instances that would be publicly accessible from the internet gateways in your account. And this is the equivalent JSON specification of that, which you can also specify manually or use it through the console. So you see here is that my source is mentioned as a resource type, and it's calling out internet gateways as my desired source, and my destination being anything that is a network interface. So what does this feature do under the hood? When you have this sort of specification and you run an analysis, what does it take for a network interface to be accessible from the internet? Number one, the network interface needs to have a public IP address. It needs to be in a VPC that has got an internet gateway associated with it, and that the VPC route table along with the various subnet route tables need to have routes pointing to the private IP address of that network interface. the subnet in which that network interface resides needs to be part of that traffic range and be allowed by the NACL on the subnet. And the security group that is applied to the that network interface has to allow that particular traffic type. And then finally, that traffic must be destined to that network interface IP address. So what Network Access Analyzer does is it is really doing and it's really constructing an end-to-end mathematical model of how VPC network connectivity works for you in the background. It is describing all of your network resources and your VPC configurations. And it is applying a technology called automated reasoning, which is nothing but it is trying to mathematically prove in your account based off the VPC connectivity principles and the way you've configured your VPC network. What are the different things? What is network connectivity like? In this case, which are the network paths that can be connected from internet gateways to your network interfaces? And what you get as an end result is an output such as this. It is listing all of the possible network paths between internet gateways and network interfaces in your account. It's showing you a summary of those different paths. And if you select any of those paths, you can also get a detailed hop-by-hop view of end-to-end connectivity that is possible between that particular internet gateway and the network interface. So for example, you can now investigate which was the security group associated with this network interface and what was that security group configuration like? Which was the route table that provided that sort of reachability? Did it have, let's say, a NAT gateway or a firewall in the path, as you might expect? And then you can also filter and search for this based off component types, sources, and destinations. Once you have the sort of an exploratory analysis done, you can then say amongst which of all these paths, which of them are acceptable. Let's say there might be certain application load balancers that you know are legit, have a legitimate need to be accessible from the internet, and maybe you don't want to be alerted about them. So you can have an exclusions clause in your network access scope, either as sources, destinations, or elements that should be in the path of the network for it to be considered a trusted or a legitimate source or a destination. And whatever is in the exclude path, these sort of situations, you will not get findings for. And so whatever is left is things that will actually produce findings when you run an analysis. Okay. So I'll quickly switch over and show you what this looks like in practice in the console. I'm just gonna switch over. So this is my VPC console. And in here, if you scroll down, this is a Network Access Analyzer. Let's give it a second to load. All right. And so when you open this console, you'll see that we have some predefined network access scopes down here. For example, things like identifying all internet egress. So let's look at this, and I've run previously a few analyses, but we'll see what it looks like, what sort of definition looks like. So this is the same example I had shown earlier, where my source is all possible internet gateways, and my destination is all possible network interfaces. And that's what we are trying to evaluate for. And this is what is showing me is that there is one single path between an internet gateway and this particular network interface. And I can also see the name of the workload or the EC2 instance that is associated with that network interface. And I can look at the pod details here, and I can see here that which was the route table that, for example, allowed that sort of connectivity, which was the subnet ACL associated with, there was firewall in the path, the VPC endpoints associated with that. And finally, it's going through a load balancer down to the network interface here. I can also create my own custom network access scopes using this feature. So to do that, as I was showing you earlier, you can specify your network access scopes using a set of sources and destinations. And so for example, you can see here, you can select from a variety of sources and destinations, not just internet gateways and network interfaces, but you can define your requirements in terms of VPCs, subnets, EC2 instances, various types of gateways or connection types. And in case you have got your resources tagged in a certain manner using resource tags, you can use an AWS construct called resource groups to create a group based off that resource tag key value pair and use that as part of your analysis as well. And in addition to resource types and resource IDs, you can also specify more granularly in terms of sources and destination IPs, what sort of traffic you want to validate for. So we'll look at this in a little bit, and we'll jump back to the presentation. So that was just a quick tidbit into what sort of analysis you can do with this feature. So I'm going to very quickly run through some common use cases on how you can use this feature for validating some of your common security requirements. So number one is just as an extension of what I was calling out earlier, identifying internet accessibility for your various resources. Now, let's say I've got my finance applications. I've got a few finance web servers running in a private subnet, and I want to find out what does that connectivity look like. This is the way I would construct my network access scope, the source being internet gateways, and the destination being the subnets, my finance subnets. As I was saying, it's not just network interfaces. You can even go more granular or more broader in terms of subnet level scopes. And the equivalent JSON representation of that we've seen here. But in terms of the destination, you can specify based off your subnet IDs as well. And what that would give you is the list of your instances in the finance subnet that can be accessed from the internet. Now, vice versa, if I want to now check from my web servers trying to reach out to the internet, what does that connectivity look like? And my expectation from a security perspective, let's say I've got a mandate saying all of that sort of connectivity always has to go through a NAT gateway and a network firewall. But let's say in this case, I have misconfigured one of my subnet route tables. For my NAT gateway subnet, instead of the next hop being the VPC endpoint so that the traffic goes through a firewall, let's say I have misconfigured it so that the traffic directly goes to the internet from the NAT gateway subnet. So what would that network access scope look like? The same thing as my source being my finance subnets, destination being an internet gateway. And what I want to do is I want to make sure that the traffic is always going through a network firewall. So one of the things I'm going to apply is an exclusion condition so that if the traffic is going through a network firewall, I'm not going to get any findings for it. And this is the JSON representation of it. So what's going to happen here is when I run this analysis, if I get some findings, these are all the paths that are going from my finance subnet to the internet that do not have a network firewall in the path. And so I can investigate these sort of paths, and if I look at the route table for the NAT gateway, it's going to show here is that I've misconfigured it as directly having the next hop as the internet gateway. So this is the way you can find out like common misconfigurations and make sure that if you've got any misconfigurations that do not meet your network security requirements. Another example, how would you perhaps validate for network segmentation? One of the commonest ways customers interconnect lots of VPCs together is using transit gateways. And they want to maintain sometimes separation between, let's say, production VPCs and your development VPCs. So how do you validate for that? So just in your account where your transit gateway is instantiated, you can specify your source as transit gateway attachments for your production VPCs, the destination being your transit gateway attachments for your development VPCs. And this is the equivalent JSON representation. And in case there is any sort of, in case there were any sort of connectivity between those production VPCs and your development VPCs, you would essentially get a network path for that. And on the other hand, if your production VPCs and development VPCs were essentially segmented and did not have any route connectivity between them, it would not produce any findings. Another common example is between your production VPCs and development VPCs. You might want that traffic goes through a firewall inspection, or maybe between a high security versus a low security VPC, there is firewall present in the network path. And so the way you would construct that is similar to the previous example, where you had a source as one of the THW attachment, the destination as being the other THW attachment, but specify an exclusion condition, saying if traffic is going through a network firewall, then that traffic is permissible and you don't want to get alerted about it. And what this policy would then produce is if there was any traffic going from, let's say, a prod VPC attachment to a dev VPC attachment that does not have a firewall in the path, you would get a finding or a path produced for it. Next is an example of validating for the traffic types and the traffic patterns itself. So for example, if you've got a requirement saying like only certain Bastion hosts should have SSH access in my environment and only from certain trusted IP address ranges. So you can specify your network access requirements, not just in terms of resources and resource types and IDs, but you can even get more granular down to the traffic type that you want to evaluate for. So for example, if you don't want to get any, if you don't expect to see any kind of SSH traffic, you can say in your network access scope that you're evaluating for SSH traffic, so TCP/22. But if that traffic is from a trusted IP address range, let's say from 53.10, which is your trusted IP address range, or it is going through, let's say, a trusted instance such as your Bastion server as the destination that is mentioned here, that would be an exclusion condition. And so what this network access scope would produce any kind of SSH access to any other instance other than your Bastion host from a trusted IP address range, and you could get alerted about it. Right. And then finally, we've got an example about private network connectivity. So for example, if you've got EC2 instances that need to talk to S3 only over private link, private network connectivity, you can construct a scope such as this. So for your S3, you've got an Amazon managed prefix list. So you would have that as one of your required destinations. And you want to ensure that that traffic only goes through a VPC endpoint. So you specify that in your exclusion condition. And so if you've got traffic that is going anything outside of VPC endpoint to S3, that sort of network path would produce a finding for you. Right? So these are just some starter examples on how you can construct your network access scopes. And you've got a lot of flexibility in how you can construct these using a variety of source destinations in your match, as well as exclude conditions based off network resource types, or based off network resource IDs, right? So for the next part, this is a quick introduction to Network Access Analyzer, but I want to invite Josh from Shure to talk about Shure. Yeah, there we go.
Thanks, Vaibhav.
Thank you.
Good afternoon, everybody. My name is Josh. I want to thank AWS and the Network Access Analyzer team for having me up here today. I work at Shure in Niles, Illinois, and I'm the manager of the network and security architecture on the New Technologies team in IT. New Technologies is tasked with bringing and architecting and deploying new IT capabilities into the organization that align with our business strategies and intended goals. Excuse me, think enterprise architecture. So Shure itself is a very old company. Since 1925, we've been market leader in audio innovation. Our most recognizable products are probably microphones. You can see through this montage some of the most iconic moments and some of the most iconic people in modern history have been captured on our products. And we can now add this iconic moment to that list because, as expected, this is being captured with Shure products as well. We do have other products outside of microphones, lots of lines that support microphones, but we have an amazing line of earphones and headphones I recommend you check out. Excuse me. As far as AWS goes, Shure has what I would call a strategic relationship with AWS, and it really started about 2 years ago. Our IT project pipeline was starting to fill up with requests for initiatives and projects from the business and product development to use AWS and use some of their native services in there. Now, we had a presence in AWS already, but it's the typical handful of disconnected accounts. A business person creates an account on a credit card and there's no IT management, there's no security operations going on there. So this was not a model that was going to scale or be tenable for us from a security operations perspective. So we decided to re-architect and rebuild from the ground up. Since then, we've built out about 30 accounts. We operate in about 21 regions, and as of the last I checked, we're at about 56 different AWS services. Now, this is not a footprint to scoff at, but I do understand that some folks have a much bigger footprint than this. Within that footprint, we are doing a variety of cloud use cases, helping to modernize our business right now, running the spectrum. We're augmenting on-prem infrastructure with storage, compute, et cetera. We are having strategic migrations of our SAP platform, building data lakes, analytics platforms, all optimized running in AWS. And also our product development teams are developing cloud-native applications to help touch our customer base more effectively. Now, security at Shure is taken very seriously. From the upper echelons of our leadership, it's a mandate coming down, and it becomes kind of a shared responsibility culture there. Not just to the company and protecting company assets and data, but our products, often our microphone products, integrate into larger partner solutions or customer solutions. Think corporate conference rooms where you have high-tech audio video. There's a lot of back-end integration that goes into that. So we have responsibility to our partners and customers there as well. From an IT perspective, we have the same problems as everybody else, and that is more work and more risk and more vulnerabilities than we do people. So we have to do basic risk management 101, tackle our high priority items, and optimize our investments that we have in technology and people to get the most value out of what we do. My particular contribution to this is in the architecture realm. I'm not going to talk about scale and flexibility. That's pretty standard fare as far as architecture goes, but I like to talk about accountability as well, and that's accountability in the technology platforms that you employ in your architectures. We all hear things in the sales pitches as we go to purchase products, but oftentimes those outcomes don't match what you were told. So the goal here is to keep your vendors accountable for what they're promising in your architectures. So fast forward to late last year, and the business has been relentlessly developing in AWS for about 18 months. We're starting to get off of our hands and knees from a capability perspective and walk a little bit, but we're also drowning a bit as well in what's happening from a security operations perspective. So we embarked in our second partnership with AWS Professional Services and executing against their core security ethics framework. The idea here is that we're going to get more automation capabilities, more centralized process control deployments, and really, like I said, get our feet under us and start to leverage more capabilities in the cloud. So as I'm doing my tasks from a day-to-day perspective, the team as well, you start to kind of see security groups in the periphery, and you'll see some of those eye-popping rules that no security person wants to see. Those bad ports, those really bad CIDR ranges, and you look at it and you think, oh my God, I hope this is something private and not publicly accessible. So now you have to take time out of your day and you have to go through and you have to do that work to figure out what is that security group attached to, who can get to it, how do you get to it. More often than not, they end up being private, relatively contained within your internal subnets, but often enough, they were publicly accessible. This is concerning. And because I'm just finding this as kind of spot checks throughout my day, what is the real scale of this problem? So we need to address the problem and we need to address it quickly. We have our professional services engagement in place, so let's scope this into those deliverables. Now, what do I want here? I don't want a massive dump of all the security rules across my footprint. I can get that in different ways, and that doesn't provide value because it already takes me enough time when I see a bad rule that I have to go create all that contextual data is this important to me or is it not? So let's start with, can you give me a list of data that gives me just the security rules that are ingress pathways from external sources into my environments? That's what I'm concerned about. That's risk management. And by the way, I also need that process and how we get there to be done with as few clicks as possible. Give me automation, make it repeatable, give me contextualized data so that my engineers can focus on the high-risk items that we can derive as much value out of the tool as possible. So with that, let me hand it to Mike, the engineer who delivered.
Thanks. Hello again, my name is Mike Virgilio, and as Josh had mentioned, I was working with him on a security ethics engagement. We were going through various controls that had been laid out in the project scope, and Josh had stated, is there a way for me to get an inventory of all resources across all my accounts that have access directly from the internet? When this came up in my head, I started thinking through, how do I build something that can automate this for him? How do I build something that will gather a list of all the resources within the VPC, all the various VPC networking components, such as route tables, security groups, NACLs? Is there an internet gateway attached to the VPC? And then I started thinking, how do I build a model to analyze all this information? And then how do I kick off this analysis? And in my head, I'm thinking, this is a massive scale, very complex problem that I have to solve. And initially I was thinking Python, Boto3 calls, and how do I package this all together? After I got past that stage, I started thinking, all right, say I do build this particular solution, and today it works. How do I ensure that the findings are accurate? How do I know that I built code that's sufficiently robust to locate all these different findings and properly process all the individual components? And finally, if it works today, will it work next week when a new feature is released with AWS or some new component comes into play? Will this process that I built continue to deliver accurate and complete results? So at this point, I told Josh, let me step back and do a little bit of research and see, maybe this has been built out there already. Someone has a framework that we can use, and we can, don't have to start from the ground floor. Through the research, initially, as I said, starting with Python, Boto3, Bash scripting, I didn't find anything that existed out there. However, it didn't take too long before I came across Network Access Analyzer, and it had been released maybe 3 weeks earlier to this coming up. So I took Network Access Analyzer within my lab. I started building some various test cases, putting EC2 instances, exposing them to the internet, tweaking them to put in one little adjustment to break that connectivity, and running Network Access Analyzer against it. And I was getting the results I expected from Network Access Analyzer as it was properly processing everything. So I knew I was onto something at that point. And then I started thinking, all right, now I have a solution which will do all the processing. How do I deploy this at Shure? How does it scale to their accounts, knowing the use case that they're trying to solve? So I started looking at the command line capabilities of Network Access Analyzer, and all the capabilities that were available through the console where I initially started my experimenting was available through command line. So what that meant was I can use Bash scripting and automate the deployment and analysis of Network Access Analyzer across the environment. And I knew that once I had put this together, it would allow me to solve the use case. So I took this solution that was in kind of a very POC state at this point, And I brought it back to Josh within days and said, hey, I found this feature of VPC, Network Access Analyzer. I believe it's gonna do what you need to do. We went through a POC, and Josh, I'm gonna quote you for a second. He said, this is exactly what I'm looking for, because it gave him the findings that met his use case that he had asked about. So we did a little additional tuning, some more testing within their environment, and eventually deployed it into production, where it now has a process to perform this analysis. We ended up with a solution that met the business objectives set by Josh. And from my side, I knew that by leveraging Network Access Analyzer, it was going to be a solution that was very robust, kept up to date with the changes in AWS, and I can be confident in the findings that were coming back because I didn't have to build this custom solution and attempt to stay up to date with all the changes. So the next thing I want to get into is a little bit of the high-level solution design related to the scripting that was written around Network Access Analyzer. So the way that the script operated that we deployed was to start by, and like I said, it was generated with bash scripting. We utilized an EC2 for this instance, but there's many other ways to build this type of solution. So the way it works is initially it will make an API call to the AWS organization to dynamically generate a list of all active accounts in their organization. So we can build this list, and as new accounts are added, we know that this list is going to contain those accounts. Once that list is generated, it feeds that list to a for loop, which will execute the next 4 commands. First, what it will do is it will assume an IAM role in the member account. We've already set up the proper permissions for this to work, by the way. But it'll assume a role in a member account. It will then check to see if Network Access Analyzer scope has been defined within that account. If it has not been defined, it will provision that scope based off of the JSON that you saw earlier. And if it does exist, it will skip over that step. Next, the script will ask Network Access Analyzer to perform an analysis within that account. Network Access Analyzer will do all the heavy lifting, perform the analysis based off of our scope, and let us know when it's done. Finally, we output the findings from Network Access Analyzer in that particular account into a flat file JSON file. And we'll loop through each of the accounts within the organization to generate one JSON file per account. Finally, once we finished with that for loop, we would take all of the JSON files and extract specific data points out of the JSON and convert it into a CSV flat file, which was the request for output of these findings. So we end up with a CSV that has all the account findings appended together, and that CSV file will get uploaded into an S3 bucket where it can be retrieved by Josh's team. So then at this point, he has a single CSV which shows all the findings across the entire organization in one single place. You can open it with an Excel, review the resource ID, the security group, the ports that are being allowed. We specifically chose information that would allow us to identify the resource and figure out what is being allowed currently from that particular snapshot. So one other thing that I'd like to get into is Josh and I had put together a wish list for the service team based off of the scripting that we had built around Network Access Analyzer. So there are a few things that we're looking forward to be released in a future version of Network Access Analyzer, hint, hint, Vaibhav. Integration with AWS organizations. So we built scripting around this to deploy at scale the Network Access Analyzer scope and perform the analysis. With integration into organizations, like many other AWS services, we'd be able to deploy Network Access Analyzer scopes across the organization in an automated fashion. And just like other services, think of, say, GuardDuty, there's a relationship which gets formed where findings from different accounts get aggregated into an admin account, and from one single console, you can see everything that's going on within your organization. when findings are reviewed and identified as known good, an exception process. So they no longer appear in the active list, but instead maybe move to an archive list, how IAM Access Analyzer performs its analysis. So a way to archive, maybe archive rules or something like that. Scheduling of these scopes. We would like to, currently right now with the script that we have, we can schedule it and it'll perform that analysis whenever we schedule it. But native scheduling within the feature would allow us to execute this analysis on whatever frequency we want, monthly, quarterly, maybe even daily if it's a high change environment, there's a lot going on, and we identify those findings quickly. And finally, native integration with Security Hub, a way to take those findings that are generated and inject them directly into Security Hub, if that's the tool that's being used, or even a way to export them directly to CSV. So this is a list of some things that we'd like to see integrated into the tool. It would allow us to reduce the complexity of the scripting that we built, and we believe it would make it more accessible to others to meet, to solve this type of use case in their environments without having to build custom scripting around it. So with that, I think I'm good. So I'll hand it back to you.
Thank you, Mike.
Thank you. Mhm.
All right. So encourage everyone to get started. As soon as this is posted, you will be able to access the product documentation or simply Google for it. And we also have published a blog around how you can use Network Access Analyzer in a continuous analysis manner using some external Lambda automation, as well as export the findings to Security Hub. And I just want to call out, there's a hands-on workshop tomorrow at 11 or 11:30, I believe. It's NIS 252. So please definitely check that out, and hopefully I'll see you there. And at this point, I'm happy to take any questions and answer anything that you might have on this topic. Anyone? All right, if not, we can call it a wrap, and thanks everyone for coming by.